Okay, so during our last class, we started talking about logarithms, and specifically we talked about these three properties of logs. Well, what we're going to do today is we're going to explore what we call the law of logarithms. Now, I asked you guys before you watch this video to complete 1 through 4 and 9 through 12. So hopefully you guys did that. Now, what I want you guys to see is how some of these law of logs are going to work. Now, hopefully you guys got that the sum of these, you would have ended up with 5. But what I want you to see now is if I took 8 times 4, I get 32. Well, this means 2 to what power gives us 32? Well, that's going to be 5. Well, here, if I have 9 times 81, well, now what we're looking at is log base 3 of 729, which log base 3 of 3 to the sixth, that's going to give us 6, just like when we added those. Same thing here. 1/9 times 81 gives us 9. Well, we know log base 3 of 9 would equal 2. And then if I had 5 times 1, I get log base 5 of 5, and that's going to equal 1. Now, what this property is, what this law is this law is telling us that if I have log base b of x plus log base b of y, they have to be the same base, that's going to equal the log of the product. So what this is going to allow us to do is it's going to allow us to evaluate some logs that we wouldn't have been able to previously. So this is the first law. So when we take a look at this, if I have log base 6 of 12 plus log base 6 of 3, well, 6 to what power gives you 12? Well, I can't rewrite 12 as a power of 6, so I can't really do anything. But because they have the same base, I can rewrite this as log base 6 of 12 times 3, which is log base 6 of 36, which will equal 2. So I could not have previously evaluated that, but now I can. Now in this next one, this brings up something that we haven't totally discussed yet. So when you take a look at number 7, do you guys see how there's no base here? That's because when you have something and you don't see the base written, this is what we call the common log. And when we have the common log, we assume base 10. So I won't ever write it in, but you guys could if you really wanted to. So these have the same base. So if I have 250 times 40, that's going to end up giving us log of 10,000. Well, remember we have the hidden 10 there, so 10 to what power gives you 10,000, and that's going to be 4. Now, similarly here, I can just multiply my 3 over 64 times my 1 over 3, and I get log base 8 of 1 over 64. Well, 8 to the negative 2 is 1 over 64, so we can then evaluate that. So this is the first law of logs. Now, when we get to our next one, I'm going to try to speed through this one for you. In each of these, now we have subtraction. And when we are subtracting two logs with the same base, we can rewrite this as the quotient. So I could have rewritten this as log base 5 of 625 over 5. Well, 625 over 5 becomes log base 5 of 125, which equals 3, which is the same thing we had when we looked at it like this, an expanded form. So if we were going to take a look at, say, number 12, if I have the difference of those two logs, it becomes the log of a quotient. So this becomes log base 2 of 1/2, which is going to equal -1. So our next rule is that if I have the difference of two logs, it becomes the log of a quotient. Now, I need to emphasize to you guys see that this log is written only one time? That is very important to remember. You're taking the log of a quotient. You're not taking the quotient of two logs. So you should not have logs on both levels. So when you guys take a look at these, if you were going to go evaluate these, log base 6 of 72 over 2 gives us log base 6 of 36, which is going to give us 2. Now, again, we have the common log, so we end up with log of 12 over 0.12. So you can go ahead and you can divide those. So 12 divided by 0.12 should be 100. I just needed to make sure you guys would have too. So if there's a base of 10 here that we don't see, 10 to what power gets you to 100? That's going to be 2. So what you're looking at right now is this is the first law, and that's the second law. Now, you are going to have another one, but honestly, I think it's the next one that's the easiest and the most useful. So when we take a look at this next one, we've talked about already that we can try to rewrite what we're taking the log of so it has the same base as our log. So here I have log base 3 of 9 squared raised to the 1/2. Wait, pardon me. 3 squared raised to the 1/2. So this ends up giving us log base 3 of 3, which is going to equal 1. Now, when we take a look at a problem like 19, well, in number 19, we already talked about that third property of logs that says if these match, it's going to equal that power. Well, one other thing that I want you guys to see, though, is there's another way to approach this. And this is with our third law. If you have an exponent, like we do here, we can move that exponent to become the coefficient. When I do that, I have 5 times log base 5 of 5. Well, I know log base 5 of 5 is 1. So now I have 5 times 1, which is just, oh, I moved it as a 5. I apologize, but I'm not redoing this video. That 2 should have stayed a 2. So when I get to this point, I should have had 2 times 1 equals 2. So again, this property allows us to simplify things we wouldn't have been able to before. Now, when I take a look at this, the rule would be then that this C here moves to the front as a coefficient. So it becomes C log base B of A. Now, just to give you all an example here, I know when I take the square root of 1,000 that that's the same thing as raising it to the 1/2. Well, if I move that 1/2 as a coefficient, now I have 1/2 times the log of 1,000. Well, the log of 1,000, common base, common log, so our base is 10. So this would end up giving us 10 to what power gives you 1,000, so that would be 3. So this is equal to 3. 1/2 times 3 equals 3/2. Here, it would just come to the front, so I have y log base n of n, and so log base n of n would just be 1, so that's going to equal y. So these are the 3 law of logs that you guys are going to have to deal with. I'm going to go through a few examples on what we would call expanding and condensing next, but this is definitely something you guys will get more experience with. So stay tuned for the next one.